Hi there, this is Tom Ingram, and in this video, we're going to take a look at Mistral AI. They just released a brand new LLM called Mixtral 8x7B. And what's exciting about this is that it's called a mixture of experts model, where it takes a variety of smaller large language models that specialize in doing various tasks, and it puts them together to create a really versatile and capable model. And in fact, when they look at the performance tests, it outperforms Llama, and it also, in certain cases, outperforms ChatGPT 3.5. And so, as much as I love OpenAI and I love their LLMs, I like having the ability to have options and to choose things, especially if it's open source. And we know that open source models are gradually becoming better and better and getting to the level of like ChatGPT 3.5 and also 4.0. So having the ability to have an open source model that you can use and you can deploy is really, really exciting. So let's go ahead and take a look at some of the benchmarks first. And then what we're going to do is we're going to test 8x7 Bravo, the instruct model, against ChatGPT 3.5. And then we're going to deploy it on our own Flowise server and test it from there. So let's go ahead and get started. So if you take a look at the performance benchmarks for Mixtral 8x7B, you can see that it does very, very well when compared to Llama 2, the 70 billion parameter model, and ChatGPT 3.5. And in certain cases, it actually outperforms ChatGPT, and it also outperforms Llama. And so it's really, really exciting. And then when you look at the performance against its own base model, Mistral 7 Bravo, it also does very, very well. So this looks like a very, very capable model. And so it's only been out just a little while from the making of this video. And so if you don't have Flowise, you can still test it on a variety of different platforms. One of the ones that you can test it on is Hugging Chat. Of course, Hugging Chat always has the latest models that come out. And so what we're going to do is we're going to check out, this is the Hugging Chat interface. You may have seen it or may not, but it's a great way to test models without having to pay for an API, and you can just check things out. Now, I've seen a lot of different ways that people test these models, and of course, there's no one test that can tell you everything. It really just depends on what you're using it for. But for this particular test case, I want to actually give Mixtral some puzzles and see how well it actually does with some reasoning and math puzzles. And so what we're going to do is we're going to test and see what ChatGPT, how it handles these puzzles. And then we're going to see how Mixtral 8x7B handles the same puzzles. So I went out and I basically found 3. And 2 I actually found, and then the other I made up on my own. And so, they're designed to progressively get more challenging. And so the first puzzle is, we call it the train journey. And so basically a train leaves from New York City heading to Los Angeles at 150 miles per hour. This is an easy question, by the way. At the same time, a train leaves from Los Angeles heading to New York City at 200 miles per hour. Which train will be farther from New York City when they meet? Okay, so again, this is very simple, very, very easy. No calculation required. So we're going to go ahead and we're going to test ChatGPT 3.5 first. So we're going to go ahead here and we're just going to copy and paste the question in. And we're going to see what it says. So it says, okay, it does some math. So it's really trying to show off here. And let's read it here. We're not going to go through everything. It says, to determine which train will be farther from New York City. So it's going to give us some reasoning, which is a good thing. We actually want to see what, instead of just giving us an answer, we want to see how well it's reasoning and what it's doing. So to determine which train will be further from New York City when they meet, we need to consider the relative distances traveled by each train. Okay, the relative speed. All right, so it's doing some math here. Looks all fancy. Time taken, compared. All right, therefore the train. Okay, so comparing the two distances, we see that D2 is greater than D1. Therefore, the train leaving Los Angeles headed to New York City at 200 miles per hour will be further from New York City when they meet. Okay. Hopefully you know the answer to this question. This is a very simple question, actually. It seems it's very deceptive, but it's very simple. Okay. So the last time I ran this, we know the answer is that both trains are actually the same distance from New York City because they're in the same place, right? So no one train is further from New York City because they're in the exact same place, all right? But ChatGPT 3.5 decided that it wanted to do some fancy math and it came up with a wrong answer, okay? Happens to all of us. So let's go ahead and check out, let's make sure that we have the right model. We do, all right? And let's see what happens. So we're pasting in the same question. A train leaves New York City heading to Los Angeles at 150 miles per hour. At the same time, a train leaves from Los Angeles heading to New York City at 200 miles per hour. Which train will be further from New York City when they meet? Okay. Okay, so the answer that Mixtral 8x7B gave us was both trains, without the fancy mathematics, both trains will be traveling the same distance, or both trains will be traveling at the same distance from New York City when they meet, since they are traveling towards each other and will eventually meet in the middle of their journey. Okay. The relative position or distance from a fixed point, in this case New York City, is not dependent on the speed of a moving object alone, but also takes into account its direction and the time it has been moving. Okay. So the answer was both trains will be the same distance. So it actually got this one correct. All right. Now to be fair, with ChatGPT 3.5, I ran this before, and I believe it actually got the right answer like a while ago. So we're all human. All right. So let's go to the second question. This is a little bit more difficult, and the second question is the torch and the bridge problem. And I actually really like this one because it takes a lot of reasoning and you have to sort of think things through. So this is the problem. There are four persons, person A, B, C, and D, who want to cross a bridge at midnight. Okay, person 1 or person A takes 1 minute to cross the bridge. Person B takes 2 minutes to cross the bridge. Person C takes 5 minutes. Person D takes 8 minutes. Okay, now there's only one torch. They're doing this at midnight. There's only one torch with them, and the bridge cannot be crossed without the torch. So they absolutely have to have the torch. There cannot be any more than 2 persons on the bridge at any time, and when 2 people cross the bridge together, they must move at the slower person's pace. All right, so you see the bridge, you see the people, and then the question is, can they all cross the bridge in 15 minutes? Now, this, they actually have the answer to this. I'm going to take a look at it first. So the solution is A and B cross the bridge. They come back, or A comes back. That takes 3 minutes. Then C and D cross the bridge. B comes back. That takes 8 minutes. Wait, let's see here. Okay, so... All right, so this particular trip takes 10 minutes, and then the last trip with A and B crossing the bridge again takes 2 minutes. All right, so basically 3 plus 10 plus 2 equals 15 minutes. So that's the answer. All right, so now let's go ahead and take this and paste it into ChatGPT 3.5. So we're going to see what it comes up with. All right, second time the charm here. Okay, so it says, yes, they can cross the bridge in 15 minutes using the following steps. Persons A and B cross the bridge together with the torch, 2 minutes. Person A goes back. Persons C and D cross the bridge together with the torch, 8 minutes. Person B goes back with the torch, and then persons A and B cross the bridge together again with the torch, 2 minutes. So the total time is 15 minutes. Okay. Now, I don't know if this was actually in the system previously. It could have been, but it got the right answer. So let's go ahead and ask Mixtral. Do the same thing. And so, yeah, so it got the right answer. So both of them got the right answer. Okay, that's good. All right, now let's go to the last question. And the last question is actually, it's so difficult that even I don't know the answer, honestly, without doing some like serious mathematics. So we're going to go ahead and check out the last problem. And the last puzzle or problem is the orbital rifle problem. All right, this is one I came up with. Okay, so let's say that I'm on the moon with a Remington rifle that shoots a 200-gram bullet that travels 3,000 feet per second. Okay, I want to hit a basketball that is directly overhead, going at 1,000 meters, or it's directly overhead at 1,000 meters, right? So the height is 1,000 meters, and it's orbiting the moon at 1,618 meters per second. Okay, what angle relative to the ground should I fire my rifle in order to hit the basketball? All right. Now, I wasn't sure exactly how it was going to answer the questions. So what I did was I asked the questions, and because I wanted to get just the same response. So I asked the questions in advance. So we're going to go and take a look at how ChatGPT 3.5 answered the question, and then we're going to take a look at Mixtral. So let's go ahead here. And again, this is the same question. I'm on the moon with a Remington rifle. I have a bullet that goes 3,000 feet per second. I want to hit a basketball that's directly overhead at 1,000 meters, going 1,600 meters per second. What angle relative to the ground should I fire my rifle? Okay. Now, this is what ChatGPT 3.5 gave me. All right. To solve this problem, we can use the equations of projectile motion. Okay. The key is to find the initial launch angle at which you should fire the rifle so that the bullet intercepts the basketball. Okay, now I'm going to spare you the math because it gives me a lot of math. And I mean, to be fair, it is an intense problem that requires a lot of calculations. Okay, it's not completely difficult, but it does take some calculations. So it gives us a lot of math. All right, and again, we're not going to bother with if it's right or not. We just want to see what it gives us. Okay, so it gives us a lot of trigonometry. And then it says, which has actually been happening for a while, at the end of this answer, it says, simplify and solve for, I believe that's theta. Okay. Please note that this is a complex equation and finding an analytical solution might be difficult. It's often solved using numerical methods or specialized software. Once you have the value, it represents the launch angle. Okay. That's great, but it's not what we want. So I asked it more specifically, okay, what's the value of theta? And so it gives me some more, reasoning, and it actually even throws Python code at me, it's always interesting. And so that's it. It didn't give me an answer. It gave me a lot of fancy mathematics and hand waving, but it did not give me an answer. Okay, so let's go ahead and let's check out Mixtral 8x7 Bravo. All right. So same question. All right. And it answered, this is an interesting problem. To solve it, we need to use some physics and calculus. All right. Here's how you can approach this. All right. So they start, giving me what I've told them, the mass of the bullet, the muzzle velocity, the target basketball, the height, the orbital acceleration, or the orbital speed. Okay. And so then it starts to go through its reasoning. Again, we're not going to check this because it's been a while since I've done calculus. But it gives us the bullet. So this is the vertical motion. Let's see here. So it takes into account gravitational acceleration of the bullet and the basketball. And then it says to find the correct angle, which is super cool, actually. It gives us this formula, and then it goes through the math. And now this is actually something that's really interesting, where it actually shows you like the mathematical formulas and equations, which is really, really helpful. But then it goes through and it gives more, And so I don't believe it. Let's see here. Okay, so in the previous run that I did this, it actually answered the question. It actually gave me a number. So let's go ahead and let's see if it can give it to me again. And let's see if it's the same. So let's go ahead here, and then let's see if it's going to give me the same. Because sometimes the mathematics, the answer is so long and drawn out that it cuts off before it gives you an answer. So let's see here. Hence the basketball, relative size and height, compensate. And it just gives us more. I mean, this is a complicated problem, so I'm not surprised. But okay, so this is kind of what it did before. Okay, so in this particular example, it actually gave me a number. And when I ran this before, it actually gave me an angle of something like 68 degrees, which sounded actually pretty reasonable. In this case, it was 145 degrees. So, I'm sure both of them were wrong, but we don't know until we actually, like run the calculations ourselves. But at least in this one, it gave me an answer. It gave me some sort of number. As long as, I guess, the context window was large enough or wide enough, it actually gave me a number. And so at least it tried. Whereas ChatGPT 3.5 just sort of like, brushed me off, brushed me aside. Like, okay, well, you go figure it out. But what I really like is the fact that it actually tried to go through some sort of reasoning process, So 8x7 Bravo is pretty good. I think it's pretty good. Now, obviously, there's a lot of different tests that you could run. But I think it's pretty versatile, and obviously it's only going to get better. The model is only going to get better. And of course, no LLM is perfect. So, even ChatGPT makes mistakes all the time, and it hallucinates all the time. So that's something to take a look at. And so now what we're going to do is we're actually going to deploy this model, 8x7B, on our Flowise server. And we're just going to test it out very, very quickly so you can see how it works. So let's go ahead and go to our Flowise installation. And as you can see here, we have a really, really simple conversational chain that we've set up. And it looks a lot like most of our chains in Flowise. The only difference is that we're using the Chat OpenAI custom module. And this allows you to use different models from different places. Specifically in this case, we're using the Mixtral model from the openrouter.io, I believe. Let's go ahead. Yeah, openrouter.ai, right? So this is another provider. It's an LLM. It's a hosting provider for LLMs. And they've got some really, really great prices, actually. But yeah, so we're hosting, we're getting our our API access to the LLM through OpenRouter.ai. And really, we just need the API key that you can get there. Let's see if we can find. So this is OpenRouter. It's a very simple looking page, but you can get API access to Mixtral and some other models as well. Yeah, if we go back and we basically can set the temperature. We have the model name here. We have our buffer memory. And so if we go ahead and we ask it, we clear it, and we say something like, what is the distance from the Earth to the moon? You can see that it gives us an answer, okay? And so what we did was we actually wanted to do something more than just question and answer, because we know it works, but what I wanted to do was actually see if I could actually do some retrieval question and answering, where we upload a document and then we ask it questions based on that document. And so what we did was we actually were using the conversation chain. And so essentially we're basically taking a file and we're plugging it directly into the chain rather than doing an embedding, which takes a little bit more time. But we're just doing a straight text file into the basically kind of into the context window, which is a very simple form of retrieval augmented generation. And so in this case, the text file is just an article on the recent price performance of Bitcoin. Okay, and so it doesn't really matter what the article is about, but we just wanted to be able to check to see if the model could actually do a very good job, or could, answer questions based on a simple document. Okay, so this is the article, and so recently Bitcoin went from, I believe it was like $40,000 or $38,000 to let's see, I think it was like 40,000. Oh, 40, almost 44K. And so what we want to do is we just want to ask it, what price did Bitcoin surge to based on the article? So let's go ahead here and let's just ask the question. Okay, so it says, in the context provided, Bitcoin surged to nearly 44,000. And if you go to the article, you can see that it says breaking through the resistance, 38K, and reaching nearly 44K. So that's good. So now let's go back and let's actually ask it a second question. What's going on with the Stacks ecosystem? And so here in the article, it says the Stacks ecosystem is making waves in the crypto market. A key driver in this surge is the popularity of ordinals, a protocol introduced on January 21st. So let's go ahead and see if it actually can find that answer or something similar. And what I like about this is that the performance is really good. And this is really, this comes down to the model and also the hardware. So we're actually using pretty good hardware on this in this case. But it says, in the provided context, the Stacks ecosystem, a Bitcoin layer 2 solution, is making waves in the crypto market. So it's getting the information from our document directly. So let's go ahead and ask it one last question. And the question is, what is the latest update on Jito? And so if you go down further into the article, it says Jito is a Solana-based crypto staking project. Okay, so let's go ahead and see how well it works. It should do pretty well. So as you can see, it does a great job of answering questions based on our documents, as well as general questions. And so while we don't know what the actual weights are, the fact that it's an open weight system that we can download it and we can install it on our own hardware is just fantastic. And it really just makes us one step closer to having open source models that are just, the performance is just, compared to ChatGPT and even Google's Gemini and some of the best models on the market today. So in the next video, what we're going to do is we're going to take this another step further, and we're going to go completely open weight, open source, and we're going to go ahead and we're going to embed some documents into our ChromaDB vector store, and we're going to use Mixtral 8x7 Bravo to basically answer questions from those documents. So it's going to be pretty exciting, and I'll see you in the next video.